Hi everyone. So consider this example 2. In this example, we have total 3 states, capital A, capital B and capital C. And the input alphabet is ABC. So here you have to be careful. Input alphabet is small a, small b and small c. And the capital Q, which is finite set of state, is capital A, capital B and capital C. Okay. And the epsilon moves are also given here. So the procedure is same. Use closure property to achieve all the states of their respective input moves, and then finally construct the transition table. Remember that the number of states always same whenever you convert an epsilon NDFA to NDFA. Initial state is also same, and the state which takes epsilon move to reach the final state in epsilon NDFA transition diagram will now become the final state in NDFA transition diagram. Okay. So in the previous video, the final states are, one is capital A. I have not mentioned here. Capital A, capital B, and capital B. So A, B, and D, all the 3 states are final state. Okay, in the previous video. So you have to correct itself. Okay. Now, so first one I will consider state A. State A on epsilon star A and then epsilon star. Okay, and for state A, epsilon star B and epsilon star, and the last is epsilon star C, epsilon star. So here 3 input alphabets are given. So we have to take on 3 moves. Okay, A, B as well as C. A on reading epsilon star will go to state A, which is trivial. Will go to state A as well as state B, and B on reading input alphabet input symbol epsilon will go to state C. So here A on reading epsilon star will go to A, B as well as C. So all the 3 states are covered. Now A on small a will define to capital A itself. B on small a, there is no move defined here. So I will write 5. 5 means dead configuration. And C on small a will also become 5 because there is no move defined for C on small a. Similarly, A on epsilon star will go to either A, will go to either B, or will go to either C. And for 5, there is no concept for epsilon move, so I have not considered this 5 state. Okay. Now A on epsilon star, consider this input alphabet B. A on epsilon star will go to A, B, C. A on small b, there is no move defined here, so I will write 5. B on small b, yes, there is a move defined here. B on small b will go to B itself. C on small b, there is no move defined here. C on small b, there is no move defined here, so I will write 5. B on epsilon star will either go to B or either go to capital C. Okay. Now the last input alphabet C. A on epsilon star will go to A, B and C. A on input symbol C will go to 5 because there is no move defined for input alphabet C. Similarly, B on C will be 5 and C on C. C on C move defined here. So C on C is capital C. Capital C. C on epsilon star will go to capital C. That's it. There is no move defined for any other epsilon symbol. Okay. So it means that A, capital A, reading input alphabet small a will go to state capital A, capital B, capital C. A on reading input alphabet B will go to state B and C. And A on input alphabet C will go to state only C. Okay, so just note it down here so that it will be useful in making transition table. A on A will go to ABC, A on B will go to BC, A on C will go to capital C. Okay, so state A is over. Now consider state B. This is epsilon star. State A is over. So consider state B. State B on epsilon star will go to B or will go to capital C. B on small a will go to, there is no move defined here, so it will go to 5. That configuration. C on A or small a is also go to 5. That configuration. That means B on A, there is no move defined here. So I will just write a curly braces, and inside the curly braces there is no symbol present. There is no state present. Similarly, B on epsilon star will go to B and will go to C. B on small b, yes, there is a move defined here. B on small b will go to B itself, and C on small b will go to 5. B on epsilon star will go to B or either C. So it means that B on small b will go to either B or will go to either C. Similarly, B on epsilon star B as well as C. B on input symbol C, there is no move defined here, so it is 5, and here C on small c will go to C. C on epsilon star will go to C. So B on C will go to C. Okay, so write all these moves here. B on small a, B on small b, B on small b, capital B and capital C. B on small c, only C. Now the last state is final state, which is C. After that, we will draw the transition table. So C on epsilon star will go to C only. C on A, there is no move. Similarly, C on epsilon star will go to C itself. C on B, there is no move. So 5, I will write 5 here. C on epsilon star, capital C. C on C, yes, there is a move defined here. So C on C will go to capital C itself, and C on epsilon star will go to capital C. So the move for C on A will be nothing. The move for C on B, nothing. And the move for C on C, small c, is capital C. Okay. So all the states are over. Now the final task is making a transition table. So in the transition table, we have 3 different input alphabets: small a, small b, and small c. And we have 3 different states: capital A. Capital A is the initial state, capital B and capital C is the final state. A on small a is ABC. A on small b is BC, and A on small c will only C. B on small a, there is no move. B on small b is B and C. B on small c will only C. Similarly, C on small a, there is no move, so I will write empty box. C on small b is also empty box, and C on small c is capital C. So this is the transition table for NDFA. Okay, can you construct the transition diagram by using transition table? Yes, you can of course construct it. It is a very simple task, so I will leave it to you. You can construct the transition diagram by using this transition table. Okay, so we have covered all the categories of finite automata without output classification. We have covered deterministic finite automata, non-deterministic finite automata, and also epsilon non-deterministic finite automata. and all of them are equivalent in power. In the next video, we will see a new concept in theory of automata.